Hello everyone, I'm glad you're back, and wait a second.
Let's try to complete all the programs under the topic of numbers as soon as possible.
Yeah, I was about to nullify the long awaited gap for uploading the video. So, as I gave my word in the previous video that we would cover all the problems under the topic of numbers within this month. So, under that division, we are going to discuss the solution of all the programs under the topic of numbers in this single video.
Pretty, isn't it? Perfectly balanced, this whole thing.
Yes. So, with no further ado, let's solve the rest of the problems from where we left. But if you're new to my channel, or in order to access a solution to the rest of the problems that we had previously discussed, please ensure that you access the same by using the card provided at the right top corner of this video or the link specified in the description. Alright, now let's begin the fifth question under this division. In this question, we are provided with the size of the array and the array elements, and we have to print 1 if the sum of the array elements is divisible by 2, 3 and 5. And if it is not divisible by any of the above mentioned numbers, we simply print 0. So to begin with, we declare A as an input variable of data type integer and array as an list containing the array elements which is given in the input. Followed by the input declaration, we check if the sum of array is divisible by 2, 3 and 5. We do this by using a modulo operator against each of the given input variables. Hence, if the sum of the array doesn't return any remainder while dividing against 2, 3 and 5, we would print 1, else we would print 0. And thus we submit our code and head to the next question. In the sixth question, we are provided with a number and our task is to determine whether the given input falls under an AJS number. We would print 1 as an output if the sum of the two digits is present in the given input, which indicates that is an AJS number. If not, we would print 0. I hope the question is crystal clear for you guys, and let's move on to the coding section. Here we obtain the input as a character, as it would be much easier to check if the sum of the first two variables lies in the input itself, and further we store the sum of the first two integer values under the variable n. As you could witness, we change the data type from the integer to string in order to check if the sum of the first two value lies in the input itself. So if the variable n is present in the input, no matter which index position it is, we would print 1 as specified in the question, else we print 0. And thus we submit the code and head to the next question. In the seventh question, we are given the size of the array followed by the array elements. And our task is to print the number which is repeated more than any other digit present among the array elements. And if there are more than one such numbers, we simply print the first occurring digit which satisfies the given conditions. So, we declare the input variables A and array to obtain the size of the array and the array elements. Further, we assign the variable m equals 0, which holds the greatest significant function to sort out the most repeated value and to identify the number with the maximum frequency. Finally, we conclude the declaration statements by assigning the variable num to the first digit present in the array elements. Here on, we declare a for loop and check whether the count of the digit is greater than any other digit present in the input list, and if it does, we assign the value to the variable num. And the point to note is if there are three values of the same repetition order, or consider the given digits. Here, we would check if the count of the repetition of one element is greater than the next element followed by it. As all the elements in this list has the same frequency, we would simply print the first occurring digit. Associated with the if loop statement, we print the finally assigned value of the variable num and submit the code. In the eighth question, we have to classify and return S if the given input, which is an integer value, is a rample number. When the sum of the first and last digit of a number is divisible by 4, then it is said to be a rample number, else we print no. So we get the input as a character and we initialize n as the length of the input. We do so for the sake of adding the sum of the last two numbers with ease. And after we declare r equals 0, we declare a for loop and increment the value of r with the last two digits of the given number. So if the value r is divisible by 4, we print s, else we print no. But it is not necessary to declare a for loop here. Instead, we could simply add the last two digits by specifying the index position respectively and achieve the same output. So we would submit this code and head towards the next question. In the ninth question, we are given with an input of an integer value and we have to print a peculiarly interesting series considering the range of numbers up to the given input. Hence, we declare a as an input variable and generate a list consisting numbers up to the given input value. Further, we declare another list and add a value 1 and store in it. Addition to it, we declare a value d which holds the absolute or the integer value of the input which is divided by 3. The reason behind declaring a variable d is that the series of values that we would print is a factorial of the factors of 3. Hence, we declare a nested for loop and under the range of the variable d, we multiply each value with the limit of the odd number present in the series. But generally, what we had done here is that we had identified the odd variables and had written the same as a list separated by spaces. So, we store and modify the value of odd with respect to each iteration of the for loop and return the list C separated by spaces using the asterisk operation. And thus we submit the code and head to the next question. Don't think this is an editing mistake, cause that was a clip that we had previously discussed under the topic of strings, I suppose, and I had given the card to access the same and ensured to make use of the time tag available in the description of that video to acknowledge the recommended content. What should I say? It's literally 22 problem statements and directing to previously discussed tutorials is pretty much an excuse. Yes, I accept it. But anyways, the problem statement for these questions is provided in my GitHub repository, which I had provided the link in the description. So, if you might require the access to the same, kindly check the link provided in the description. Alright, let's move to the 11th question. In this question, we are provided with a list which consists of an array of elements and a number followed by the list in the next line. We should check whether the given elements in the array is divisible by the number specified. If it does, we print 1, else we print 0 corresponding to the number itself. So let's begin to solve the program. By declaring the input functions, we declare variable n in order to obtain the size of the array and a as a list to obtain the array elements. Finally, we declare b as the denominator or the number to obtain and check against each number in the list provided and to return 1 and 0. Followed by the input declaration, we declare a for loop in the range of size of the array and we check if each element is divisible by the denominator or the variable b using the modulo operator in the if condition. If it does, we store the value 1 at its corresponding index position, else we store 0. Finally, we print the list separated by spaces using the asterisk symbol in the print function with the suffix of the list modified. In this question, we are provided with the size of the list associated with the variable k and list elements. Here we have to print the index position of the nearest smallest number close to the variable k or the number equal to it. And if there isn't any such number, we have to print -1. But theoretically speaking, would there be any value lesser than variable k in the entire list? Well, it would be definitely a considerable query under the platforms such as HackerRank and LeetCode, where factors like time complexity and numerous other data type inputs instead of the desired condition exist. So we would encounter many other complex problems and end up modifying our perfect code. But here, it's not the case, and let's proceed to the program statement. So we pass the input values as a and k to obtain the size of the array, and finally we print the list as a variable array. Then we pass a for loop where we iterate through each element and check if any nearest small digit equal to the value of k exists. We do so by using an if condition statement. And if the condition passes, we store it in a list. And at the end of the for loop, we sort the obtained list in the descending order and we simply print the first element existing in the list. We do so in order to identify and print the smallest number or the number equal to the given value k. And the point to note is that we print the index position of the value present in the new list, and thus we would be able to satisfy all the test cases without passing the condition to print -1. You may pass the else condition for a more logical code and to obtain the exact results by passing various other input values. In the 13th question, we should check if the given number lies in the median of the given array, which means we should print the number of variables we should add in order to promote the variable to the middle of the array, or if it lies at the index position above or higher than the middle element, we should bring it back by demoting it from the respective position to the middle element. So let's begin the coding section with first importing the math library. And here on, we declare a array and the variable k to obtain the input specified in each consecutive lines. And disregarding if the number is even or odd, we divide them by 2 and use the library function ceil. The ceil function just elevates the decimal value to an integer by adding one value or the number 1. Finally, we declare variable count as 0. This would be useful for us in order to count the number of times we modify the array. Followed by the declaration statements, we declare a while loop and check if the numbers lies in the middle of the array. If it does, we add or remove numbers in the array and print the count of the number of times we had added or removed any element to make the variable k as the median of the list using elif statements, and we print the count if the condition is satisfied. Well, this condition works fine, but had failed to execute one of the test cases given in the Guvi compiler. So I figured out another random simple and output based solution which only passes these two test cases, unlike the one which we had solved earlier. So I have provided the same in the GitHub repository and you may access the same. And there are some issues that I figured out in the 14th question, so we will discuss it later and we will step into the 15th question. In the 15th question, we should figure out if the input passed is a saturated number. A saturated number is a number consisting of 2 digits or less than 2 digits. And here we pass n as an input character and b as an empty variable. We check if the number of digits in the variable is 2 using a for loop. We do so by storing the number of integers present in the given input under the variable b, and using an if loop condition, we check if the length of the variable b is 2. If it does, we print saturated, else we print the word unsaturated. It is pretty simple and we could do it also simpler. Either of these codes passes all the test cases, and concluding the two efficient possibilities, let's head towards the next question. In the 16th question, we are given with a number and we have to shuffle or print the smallest number found by rearranging the digits in a manner that the sum of the factorial of digits result back to the same input. So we obtain the input using the variable n and declare s as an empty variable. Further, we declare an everlasting while loop where we initialize two variables, namely k and I, to the value 1. We declare another while loop under the condition where k is lesser than or equal to the variable n. If it does, we find the factorial of each number in the input digit and store it under the variable s. We do it with respect to the number of digits present in the input and finally print the smallest number by reversing the variable s, where we check if n equals k. Here also, we don't need to provide conditions to print -1 as it would be taken care of. Let's step into the 17th question. I guess this is the most simple question under the entire topic of numbers, where we just get a list and provide the minimum value of the array using the minimum function. It is as simple as that. We submit the code and proceed to the next question. In the 18th question of the topic numbers, we are provided with the list and we are required to print the smallest number which is not present in the sum of the list and in the array of elements. For example, consider the given array elements. Here we should sum up the list elements with each other and store the result in another list. From there on, we should print the smallest number not present in the LST list. So let's declare a variable a and array to obtain the inputs respectively. And further, we declare an empty array s to store the sum of the array elements. Followed by declaring an array, we declare a nested for loop statement to add the sum values. Here we append the sum values to the list s with respect to each for loop iteration. Till now, we had stored the sum values, and now we have to check if it is greater than the minimum element in the array, and additionally, it should be not in the list. So if these conditions are satisfied, we print the particular element and exit from the for loop using the break function. Thus we pass all the test cases. In the 19th question, we are given a number and we have to determine whether the given number is zx. And if it is not, we print the three numbers which when added returns the input value and has the HCF equal to 1. So we declare the input variable a and an empty list named prime. To store the prime numbers, we would use the prime list to sort and find the three prime numbers with HCF equal to 1. Well, this question is a pretty big one, so let's segregate it into three parts and discuss it one by one. Okay, so in the first part, we will declare a nested for loop statement and append the prime numbers. In order to do so, we declare an if condition statement and avoid numbers which has 2 or more factors and store the rest of it in the list. In the second part, we declare an empty list named ans and add variable s to 0. Further, we declare a for loop indexing to each value in the list prime, and under each iteration we increment the value of s to each value of the list prime. We declare an if condition statement where we check if s is less than or equal to a. If it does, we append the variable I to the list ans, else we nullify the value of s and check whether the difference between the input variable and the variable s is in the prime number. If it does, we append it in the list ans too, and we break from the else condition and continue the same with respect to iteration part. And now we have reached the third and most crucial part of the question. If there are 3 values in the list, we print them separated by spaces as it should be equal to the HCF of 1, as it is mentioned in the sample output. Else, we initialize an empty list and initialize a variable x to 3 times to each element present in the list. We could refer to each element with respect to the for loop statement. And if the value equals the input, which here is 9, we store the value I 3 times, as you could see 3 plus 3 plus 3 equals 9, and therefore we return the list separated by spaces. I hope the problem was clear. If not, please try to revise the same. In the 20th question, we are provided with an array and we have to find the maximum number of elements which while added returns 0. So in order to do so, the list must contain at least one negative number to return 0, or there should be 2 zeros to return the same, and as you could witness, all such conditions are present in the sample input statement. I thought it's a point to note, so I specified it here. Alright, so now let's declare the input statements n and array to obtain the input as specified, and we declare an empty list to make note of the possible values that when being added return 0. Now let's declare a nested for loop, and under the same we declare another for loop ranging from the intervals of the first and the second for loops. So we append the values and store it under the list lst as an array. This condition repeats for each respective iteration. Thus, while we exit the for loop, we declare a variable m to the length of the first array stored in the list named lst. Followed by it, we declare flag as false and another for loop which refers to each array present in the list. And if the sum of the array is 0, we store the length of the array to the variable m and modify the flag to true. Finally, we print the length of the array whose sum is 0. And if there isn't any variable satisfying the same condition, we print -1. I understand that these problem statements are pretty difficult to figure out, but the last 2 questions would comparatively seem easier. In the 21st question, we are given with a number and we should print the pair of numbers which when added returns the input itself. So we declare a as an input variable and the variable count to 0. This variable count performs the function to hold the number of pairs that return the same input while being added. So in order to form a pair of numbers under the given input, we declare a nested for loop statement ranging from 1 to the input variable a. And thus we add the variables I and j and check if they equals to the input a using an if condition statement. Finally, we increment the value of count with respect to the condition which we discussed right now. So at last we print the value of the variable count. Hence we would pause all the test cases and let's head to the next question. We have reached the final question under the topic of numbers. Well, in the 22nd question, we are provided a number and we have to print the DFG values up to the given index position, which is the input number itself. We will begin the coding section by declaring an input variable num, and followed by it, we initialize a list array with the value 1 and another variable I to 0. To print the number up to the given input index position, we declare a while loop under a condition where the length of the given list doesn't equal to the input obtained. We increment the value I with respect to each iteration and provide an if condition and check if the variable I is divisible by 2, 3 and 5, which constitutes the DFG number. If it does, we append the values to the list array. And finally, we print them separated by spaces using the asterisk operation with the suffix array in the print statement. So all the test cases has been passed. Well done guys, we had covered all the 22 problem statements under the topic of numbers. Wait a second. the 14th question, so we will discuss it later. Alright, 21 problem statements under the topic of numbers, and we will discuss the solution for the 14th question soon enough. That's it for today, and thanks for watching this video, and we will meet soon with another problem statement.